Hi to all. Now today I am going to start the next chapter, that is fifth chapter. Its name is Magnetism and Matter. This is our chapter. In this chapter we are going to discuss about the magnetism and their properties, magnet and their properties, okay, and which matter will behave as magnet, that all things we are going to discuss. And firstly I am going to give some idea, that is electrostatic analog of magnetism. What is the relation between the electricity and magnetism? And now some few formulas in electricity and magnetism are similar, and that formulas I am going to explain. You listen very carefully, and this is our topic is very important. And first let us go for one table I will give which links the electricity and magnetism. Okay, and now our heading is electrostatic analog of magnetism. Okay, first electrostatics. In electrostatics what we will take and how it will changes in the magnetism, that I will explain. Okay, and this is magnetism. First, in electrostatics we have the electric dipole, okay, or we have the two charges instead of charge. Okay, here we will take the charge, some terms charge we will take as q, instead of charge here we will get the pole strength. Okay, and here dipole moment, electric dipole moment we will take as p. Okay, electric dipole moment as p, electric field intensity E. Okay, and these terms will changes in this, that is we will take the instead of charge we will take the pole strength. Okay, that is denoted with the small m, and electric dipole moment is p, magnetic dipole moment is capital M, and the next electric field intensity is there. Electric field strength find out current. To find electric field strength we will use the electric field intensity term, and to find out the magnetic field strength then we will use the magnetic induction term. Okay, let's now first one formula I will give, the Coulomb's law, force between two charges. Coulomb's law, force between two charges. This is q1 charge and this is q2 charge. Force between the two charges in the free space. Okay, force between two charges. Force in free space. What is the force? The force in free space formula is 1 by 4 pi epsilon naught into q1 q2 by r square. This we know already. In medium we write force in medium. Okay, force between charges in medium we write like this, that is F is equal to, we write as 1 by 4 pi epsilon into q1 q2 by r square we write. Here this is epsilon and this is epsilon naught. Here the relation between the epsilon and epsilon naught, relation between epsilon and epsilon naught is epsilon is equal to epsilon r into epsilon naught. What is epsilon r? Epsilon r is the relative permittivity. Okay, next now we will go in magnetism how it will be there when we have the two poles. Okay, this has the pole m1 and this is m2, and the separation between the two poles is r. Now the force between the two poles is there, right? Force between the two poles in free space. Okay, force between two poles, that formula is nu naught by 4 pi into m1 m2 by r square. This is the formula for the force between the two poles. This is north pole, this is south pole. the two poles are either attract or repel with each other, that attraction or the repulsion force, right? This is the Coulomb's law in magnetism, we will tell. And the next force between the two poles in medium we write, in some medium, okay, in medium. Then how we write the force? The force in medium we write as, instead of mu naught we write mu, where mu by 4 pi into m1 m2 by r square. What is mu naught in this? Mu naught is the permeability of free space. Its value is 4 pi into 10 to the power of minus 7. Mu is the permeability of medium. This is the force between two poles in medium. We take the medium permeability. Force between two poles in free space. Right? In free space we will take the free space permeability. Mu naught is the permeability. Now relation between the mu and mu naught. Relation between mu and mu naught is mu is equal to mu r into mu naught. Okay, right. And now I am going to continue comparison of the formulas in electrostatics and magnetism. In electrostatics, Coulomb's law is this one: force between two poles, force between two charges. Here the force between two poles. Okay. Now you take the screenshot and I will continue after rub. Okay, I will rub and then I will continue. Okay, now I am going to continue the comparison of the formulas in electrostatics and magnetism. This is electrostatics. In this we have epsilon naught. Epsilon naught is what? Permeability of free space. Not permeability, it is permittivity, right? Epsilon naught. In the force formula we got the epsilon naught, that is permittivity of free space. We take permittivity of free space. Epsilon is the permittivity of medium. Epsilon r is the relative permittivity. Here in previously we got the terms. What is that? Mu naught, permeability of free space. And mu is the permeability of medium. And mu r is the relative permeability. Next, this is about Coulomb's law in electricity and magnetism. Third point I am going to tell, electric field intensity. Electric field intensity formula is E is equal to, we have formula. Okay, electric field intensity formula is F by Q. Okay, not electric field intensity due to point charge I will write. Electric field intensity due to point charge. What is the formula for the electric field intensity due to point charge? This is Q charge and at a distance R I want to find out the electric field. Right? What is the formula for the electric field? Electric field formula is 1 by 4 pi epsilon naught into Q by R square. This formula I want to write in the magnetism. That is the magnetic induction we will tell, or the magnetic field strength. Magnetic induction or the magnetic field strength we will tell. This is This is a pole strength M. From here at a distance R, if you want to find out the B, magnetic induction, the formula for the magnetic induction is mu naught by 4 pi into small m by r square. Next, I want to write the electric field intensity formula on the axial line and equatorial line of dipole. Electric field intensity on the axial line of electric dipole. Okay, electric field intensity on the axial line of electric dipole. This is minus q charge and this is plus q charge. Separation between the two charges is 2L. From the center at a distance r, here I want to find out the electric field intensity. What is the formula for the electric field intensity on the axial line? That electric field intensity formula, in case of short dipole, I am going to write, that is 1 by 4 pi epsilon naught into 2p by r cube. This is only in case of short dipole. In case of short dipole means its length is very less comparing to distance. Okay. Now similarly here, what is the magnetic dipole? Magnetic induction on the axial line of magnetic dipole. Okay, what is a magnetic dipole? Magnetic dipole is nothing but, okay, it is a magnet. The magnet is called as magnetic dipole. This is south pole, this is north pole. The two poles have the pole strength small m and small m, and the distance between the two poles is 2L. And from here at a distance r, right, at here I want to find out the magnetic induction. The formula for the magnetic induction in case of short dipole, okay, in case of short dipole is mu naught by b suffix a I wrote, magnetic induction on the axial line, that is mu naught by 4 pi into 2m by r cube. This is the formula. But what is capital M in this? Capital M is the magnetic moment. Capital M is the magnetic moment. What is P? Electric dipole moment. Okay. Take the screenshot and note it, and some more points I will give. This magnetic dipole is nothing but magnet only. This we will take it as magnet also. Okay, south pole, north pole. Equivalent opposite poles makes the magnetic dipole. Okay. Equivalent opposite charges makes the electric dipole. Now I am going to explain the sixth point. What is that? Sixth point is that electric field intensity on the equatorial line of short dipole. Okay, right, this is electric dipole. What is this? This is minus q charge, this is plus q charge. This is electric dipole, its length is 2L. From the center at a distance r, I want the electric field intensity here. This is the electric field intensity direction. Now electric field intensity on the equatorial line formula is 1 by 4 pi epsilon naught into P by R cube. This is also in case of short dipole. Okay. And the next sixth point I will write in this also. Magnetic induction on the equatorial line of short magnetic dipole. Okay, this is a magnetic dipole. This is the south pole and this is the north pole. Two poles, each of pole strength is small m and small m. The distance between the two poles is 2L, and from the center, this is the line passing through center and perpendicular to its length. At a distance r, I want to find out the b. That b direction will be like this there. Okay, then the b on the equatorial line formula is mu naught by 4 pi into m by r cube. This is in case of only short dipole. Okay, right. Now what is electric dipole? Actually this we have to tell firstly. Electric dipole is what? Electric dipole moment we are using. Electric dipole moment. Okay, what is electric dipole moment? This is electric dipole, equal and opposite charges. It will gives the electric dipole. It is called as electric dipole. Two poles, two charges. The dipole moment direction is minus q2 plus q. Okay. Its formula is product of magnitude of charge and separation between the two charges. This is the dipole moment. It is a vector. And its direction from minus q2 plus q. Direction is minus q2 plus q. What about the magnetic dipole moment? Magnetic dipole is what? And magnetic dipole moment is what? We know already. Yes. This is south pole and this is the north pole. The two poles have the pole strength m and m. There is some separation between the two poles. From the center, the left south pole distance L. From the center, north pole distance is L. And this is a magnet. And the magnetic moment direction is from south to north. That is capital M. Magnetic moment formula is product of pole strength and separation between the two poles. That is nothing but dipole length. This is the magnetic moment. Okay. And here magnetic moment is a vector. It is a vector. Its direction is from south to north. Okay, south to north. And this is the magnetic dipole moment. Now the torque on electric dipole. Torque on electric dipole. Torque on electric dipole in uniform electric field. Torque on electric dipole in uniform electric field. This is electric dipole. This is placed in the electric field. Okay, like this. This is the electric field. Okay, the dipole moment is minus q2 plus q. The torque will act, the torque formula we know already, PE sin theta. Yes, this is the PE sin theta. Torque on magnetic dipole in uniform magnetic field I want. 8th point. Torque on, that means what is this? Magnetic dipole means is a magnet. Okay, torque on magnetic dipole. Magnetic dipole means two poles it should be there. That is nothing but magnet only. Torque on magnetic dipole in uniform magnetic field. Magnetic field. That formula is MB sin theta. Capital M, capital B sin theta. This is a magnetic dipole, south pole and north pole. This is placed in the magnetic field. Magnetic moment direction south to north. This is capital M and this is B. There is some angle between the M and B, that is theta. Okay, right. And the next more 1-2 points I will give, and after that I will close this comparison. Okay, let's take the screenshot. Next, I think 8th point we discussed. Next 9th point I am going to tell. Okay, that is work done to rotate electric dipole. Work done to rotate electric dipole in uniform electric field. Yes, what is the formula? Work done to rotate an electric dipole. For example, this is an electric dipole. Minus Q and plus Q. Initially it is making theta naught angle with the electric field. Now after rotating, due to the torque it will rotate. After rotating, the new angle is theta. Then work done to rotate a dipole from theta naught to theta. That formula is PE into cos theta naught minus cos theta. This is the formula. Okay. The same formula I am going to write in the magnetism. Then how it will be there? Work done to rotate a magnetic dipole from magnetic dipole in uniform magnetic field. In uniform magnetic field. That work formula is, instead of electric dipole moment, here magnetic dipole moment will comes. Instead of electric field, magnetic field will comes. The angles are same, cos theta naught minus cos theta. Here we are rotating the magnet from this. Initially it is making theta naught angle. Then after that it will rotate. Finally it is making some angle, right? That is theta. Then the work done to rotate from theta naught angle to theta in the magnetic field. The next point is the last point. Okay, right. Potential energy of electric dipole. Potential energy of electric dipole, potential energy of electric dipole in uniform electric field, in uniform electric field. What is the potential energy formula? That we know already, minus PE cos theta, right? That is minus P bar dot E bar. Okay, and here stable equilibrium condition, the dipole moment is P is the dipole moment, E is the electric field intensity. This is P and this is E. Angle between the P and E is theta. Okay, for the stable equilibrium of dipole, what is the condition for the stable equilibrium? The theta must be 0, right? And unstable equilibrium condition, here we will get theta is 180. What is theta here? Theta is angle between P bar and E bar. Okay, right, now let us go for this. Here we write potential energy of magnetic dipole in uniform magnetic field. That formula is minus mb cos theta or minus m bar dot b bar, where potential energy is U, this is U. Okay, then the condition for the stable equilibrium, theta equal to 0. Condition for unstable equilibrium, theta is 180. And theta is what at here? Angle between M bar and B bar. Okay, right. This is the comparison of formulas in electrostatics and magnetism. It was very simple. In whatever that formulas that I said, 10 formulas and 10 points I said in the magnetism, and that are already we discussed and we derived these all formulas in electricity. But in magnetism we are not going to derive. Directly we want to use. But when you want to use directly, then how to use? Just you have to change the few terms. Okay, for example, here work done formula is there. PE cos theta not minus cos theta. Instead of electric dipole moment, here magnetic dipole moment will comes P. In place of P you will get M. In place of electric field, here magnetic field will comes. That's all. And one more point it will changes, the dipole moment. Instead of charge, here pole strength will comes. Force exists between the charges. Here force exists between the poles. That instead of Q1, Q2, here M1, M2 pole strength will comes. Small m1, small m2. Just you have to change the charge Q with the pole strength small m. And electric dipole moment P you have to change with the magnetic dipole moment capital M. Electric field intensity capital E replaced with magnetic induction capital B. That's all. You will get all formulas in magnetism. We need to by heart these formulas. Okay, when you know the electricity formulas, then automatically you know the formulas in the magnetism, because both are comparable. Only instead of electric dipole moment we write magnetic dipole moment. Instead of electric field intensity E we write magnetic field intensity B. Okay. Instead of dipole moment P we write magnetic moment capital M. Instead of charge we write pole strength, right? Okay, I think you understood everything. If you have any doubt you can comment and you can ask me personally through my WhatsApp number, and everybody already knows about my WhatsApp number. Okay, thank you for watching my lectures, and till now if you not subscribe my channel and share to your friends. Thank you.